So in this video, I'm going to be explaining how I did the kitchen lab number 5, as well as how I did the calculations for the mother solution, as well as for the other solutions. The materials I used for this experiment were a tablespoon, a cup. For the solid, I used emergency dietary supplement, which is mainly made out of fructose, 5 clear glass cups, and a source of water, which could be tap water or drinking water, but in this case I used drinking water. So this is a procedure on how I did this kitchen lab. I started off by pouring a cup of water into the mother solution, after which I stirred in 1 packet of emergency. For the remaining 4 cups, I poured in 9/10 of a cup of water, or 14 tablespoons. I did this so that the amount of solution would equal a cup after I added the liquid from the previous solution into the next one. So for the second solution, I withdrew 1 tablespoon from the mother solution, poured it in, did my calculations. Then I withdrew another tablespoon, poured it into the third one, did my calculations, withdrew a tablespoon from the third one into the fourth one, did my calculations, and finally withdrew 1 tablespoon from the fourth one into the fifth one and did my calculations. Now I'm going to be explaining the lab calculations. So as I mentioned before, I used emergency dietary supplement as my colored solid. Each packet has 9.1 grams, and the main ingredient for it is fructose, and the formula for that is C6H12O6, and the molar mass is 180 grams per mole. In the mother solution, I had 1 cup of water, or 0.236588 liters of water. So to find the number of moles of solid added, I divided 9.1, which is the grams of the colored solid, used by 180, which is the molar mass of fructose, and I got 0.051 moles. So to find the molarity, I divided moles of the solid, which is 0.051, by the liters of the solution, which is 0.236588, and I got 0.22 moles. So in the second solution, there was 9/10 of a cup of water, or 0.212929 liters, and 1/10 of transferred solution, or 0.0236588 liters. And to find the molarity, I used the dilution equation, which is M1V1 equals M2V2. So I isolated the M2 by dividing V2 on both sides. So the equation that I got was 0.22, which is the molarity of the first solution, times 0.0236588, which is how much there was of the transferred solution, divided by 0.2365878, which is how much there was in total for the second solution, and I got 0.022 moles. In the third solution, there was 9/10 of a cup of water, or 0.212929 liters, and 1/10 of the transferred solution, or 0.0236588 liters. Again, to find the molarity, I used that dilution equation and I isolated the M2 by dividing both sides by V2. And so the equation was 0.022, which is the molarity of the second equation, times 0.0236588, which is how much there was of the transferred solution, divided by 0.2365878, which is how much there was in total in the third solution. And I got 0.0022 moles. The fourth solution had 9/10 of a cup of water, or 0.212929 liters, and 1/10 of transferred solution, or 0.0236588 liters. Again, this is the dilution equation, and it ended up coming out to 0.0022, which is the molarity of the third solution, times 0.0236588, the amount of transferred solution, divided by 0.2365878, which is the total amount in the fourth solution, and it equal to 0.00022 moles. Lastly, the fifth solution. There was 9/10 of a cup of water, or 0.212929 liters, and 1/10 of the transferred solution, or 0.0236588 liters. The equation was 0.00022, which was the molarity of the fourth solution, times 0.0236588, which was the transferred solution, divided by 0.2365878, which is how much there was in total in the fifth solution, and it equaled out to 0.00022 moles.